Now we're going to look at an application of recurrence relations. So let's look at the following problem. On your 21st birthday, you get a letter informing you that on the day you were born, you had an eccentric and rich aunt that deposited $100,000 in a bank account, earning 4% interest compounded annually, which just means you earn interest once a year. And she now intends to turn the account over to you, but there's a catch, provided you can figure out how much it is worth, how much money is in the account. So, what is the amount currently in the account? So in order to get that money, you have to know exactly how much is in the account presently. You're basically going to get one shot at this and you don't want to mess it up. So what I want us to do is we should think about this problem recursively. So let's say I am looking at how much do I have the amount at the end of the year. What would that be equal to? Well, it's how much money you started off with at the beginning of the year. So the amount at the end of the previous year plus, well, however much money the account made, the interest that you earned. So plus the interest earned during the year. All right, so I'm going to use the variable an to represent the amount in the account at the end of year n. So what we're going to do is we're going to take and translate this kind of wordy equation I have up here into symbols. So the first thing is we know the initial amount in the account, A0, the aunt put in $100,000. And now let's translate that sentence equation into an actual equation. So the amount in the account AK at the end of year K will be the amount at the end of the previous year plus how much interest I earned that year. Well, we're getting 4% interest on the amount from last year, at the end of last year. So it's 0.04 times how much I had at the end of last year. So I can simplify this equation to be a little bit nicer. AK, if I factor out AK minus 1, it'd be 1 plus 0.04, or 1.04. So here's our recursive formula. So now that we have that, in order to answer our Ann's question, what do we need to know? We want to know A21. How much is at the end of year 21? So we know A0, we can use that to find A1, plug in K equals 1 into our recurrence relation formula. And we'll get how much we have at the end of year 1. And then A2, 1.04 times the amount at the end of year 1. And unfortunately, you have to do all these calculations because our formula is a recurrence relation. You're going to have to keep going until you get to A21. And if I did my computation right, it should be $227,876.81. So that is the exact amount we want to tell our aunt, and then we will get all of that money on our birthday. All right, so I do want to make a comment about what happens when it's not compounded annually. Your interest rate is compounded at in a different increment. So we're going to note that when an annual interest rate of I is compounded M times per year, the interest rate paid per period is going to be found as I over M. So, for example, if we're looking at a 3% annual interest that's compounded quarterly, quarterly would be 4 times a year. So you would take the interest rate of 3% and divide it by 4 quarters. So you would get 0.75%, and that's how much interest is paid per quarter. So how does that affect your calculations? So now I would use PK for the amount deposited at the end of the kth period. So then PK would be PK minus 1, your previous amount, plus the interest And now your rate is I over M. And so if you factor out pk minus 1, you're going to get 1 plus I over M. Okay, so this is how your recurrence relation would work if you're compounded more than once per year.